All right, okay, we're going to go over some beginning of proof ideas. What we have here this is the reasons for proof worksheet, and if you can understand some of the reasons of the proofs and what to look for, it might make identifying them in your proof a little bit easier. So the first couple of sections are, excuse me, the different types of properties we can use, just kind of like math properties that we already know. Like addition property allows you to add a number to both sides of an equation. Subtraction property allows you to subtract the same number or same thing from both sides. Multiplication property allows you to multiply by the same thing on both sides. And division property allows you to divide by the same thing on both sides of the equation. These are just general rules that we use when we solve the equation x plus 3 equals 5. If I'm going to move the 3 over, I need to subtract that 3 from both sides. This would be using the subtraction property that I'm doing that. Substitution property takes two equations and combines into one. And the rule is, with substitution property, you're going to see addition and subtraction in your actual equations that you're substituting. So an example of substitution would look like, if I came over here, if I had the equation x plus 3 equals y and 2x also equals y, they're equal to the same thing, so I'm going to combine. Instead of saying they're equal to y, I'm going to replace the y with 2x in the first equation and say that x plus 3 equals 2x. So maybe step 1 would be this equation, step 2 of a proof would be this equation, step 3 would be the combined equation. I'm combining the equation. My reason for this would be substitution. Distribution property allows you to distribute across parentheses. So if you had 3 times x plus 5, you could use distributive property or distribution property and say that that's equal to 3x plus 15. Now, reflexive, symmetric, and transitive are properties that allow us to combine things. And the way I remember this is R, S, T, and 1, 2, 3. So numerically it goes numerically it goes 1, 2, 3. Alphabetically it goes RST, so that allows me to say, okay, reflexive property compares one thing. So for example, A is equal to A, or the measure of angle B equals the measure of angle B. It's the same on both sides of the equation, so it allows me to say that that's reflexive. Symmetric property, uses two things and just flips the order. So maybe I start with the equation A equals B and then flip it. I can also say that B is equal to A. So maybe step 1 would be that, oh, okay, well, angle A is congruent to angle C, and then I can conclude in my next step that angle C is congruent to angle A by symmetric property. I'm taking the same thing and just flipping it over. Transitive uses three things. Transitive and substitution are very like. Transitive allows me to take two equations, these two specifically right here, and combine them into a neater property. And I can do that when they're the same, like A is equal to B, but B is equal to C. If they're the same in the middle, I can just say A is equal to C and cross over. It's a combination of equations into one neat, concise equation. The difference between substitution and transitive just has equal signs or congruent signs, while substitution has addition and subtraction in there. So if you come to something that's a combination of two equations into one, then look for those addition signs. If you see the addition subtraction signs, you'll put substitution. If you don't, then you'll conclude it's transitive. Angle addition property is very generic, and so is segment addition property. Angle addition would be like if you had a picture of two angles, like angle 1 and angle 2, and we'll call this angle A. Then very generic, no numbers, just names. My angle addition property would say that the measure of angle 1 plus the measure of angle 2 equals the measure of angle A. It's the little plus the little equals the big. Segment addition is the same thing. Say we have a segment and it's broken into X, Y, and Z. I don't know their measures, so it's very generic, very name based. I can say that the little piece xy plus the other little piece yz is equal to the entire piece xz. So these are what you would recognize in a proof. And the difference between like angle and segment addition as opposed to regular addition property you would see like, let's say 2x plus 7 and 5x plus 7. Do you see how I'm adding on both sides the same thing? That would be addition property. With angle and segment addition, you just see angle addition on one side of the equation, not on both. All right, definition of a right angle would be, and definition of anything changes from one step talking about words or about vocab, and then the next step switching to numbers in the equation. Oh, sorry, you can't see what I'm writing. Hello. So you start with one step talking about the vocab, like angle 1 is a right angle, and then switching to the numbers of that. Well, if I know that angle 1 is a right angle, I can say that the measure of angle 1 equals 90 in my next step, so that I can use, like the whole idea of your proofs is to be able to use equations to manipulate stuff. Definition of an angle bisector. Angle bisector would be if you have an angle that's cut exactly in half, and we'll call that angle 1 and 2. If you have definition of an angle bisector, I'm not going to write angle bisector over and over again. I'm just going to say that those two angles are congruent. So I would go straight to, in my next step, angle 1 is congruent to angle 2. Segment bisector and midpoint are actually kind of very similar. It would be if you had a picture of a segment and I told you that B was either the segment bisector or the midpoint, and I'm using my vocabulary to say that, then the next step would be, oh, well then these two pieces must be equal. So I would say that AB is congruent to CB. Complementary angles, definition of complementary. Anytime I tell you two angles are complementary, that means that the measure of them adds to equal 90. So that would be my next step. And if I told you, hey, angle 1 and angle 2 are supplementary, that would mean that I could write the next step to be angle 1 plus angle 2 equals 180 degrees. If I told you something was a linear pair, you could also say that those angles add to equal 180 directly in your next step. Definition of congruent angles and congruent segments are very similar. Anytime you use, you start with saying like angle 1 is congruent to angle 2, I know what congruent means, so my next step would talk about their measures being equal, and I would say angle 1, the measure of angle 1 is equal to the measure of angle 2. And I could go vice versa. If I told you that the measures were equal, I can use definition of congruent angles to say, well, that means that those angles are congruent. Same thing with segments. If I told you that AB is congruent to DC, then I could conclude that the measure of AB and the measure of DC are equal to each other. And vice versa. If I told you the measures are equal, I can use definition of congruent to say that that means their segments are congruent. The rest of these segments, or sorry, the reasons for this is something that you'll probably use a little bit later on. This is just for Unit 2 reasons right now, so it kind of narrows it down a little bit. Another thing I want to kind of intro to you is there's not like generic steps to your proof, but there are kind of an order that you want to follow. Generally, your proof needs to start out with your givens. And your givens can include anything, like I tell you angle measures, I tell you vocabulary words, anything like that. The next step you want to do is define your given vocab. So if there's a vocabulary word in the given, your next step should be defining that vocabulary word using this chart that we just did. Anytime we used our vocab words, we could change it into an equation. If there are no vocabulary words, then you would have gone straight to step 3. Step 3 is a pull from the picture thing. Things you can pull from the picture are linear pairs, segment addition, little plus the little equals the big, angle addition. Those are the kinds of things that you can pull from the picture. And the reason I know I'm pulling from the picture is because it's a new angle or a new segment piece that I haven't actually talked about yet in a step above. So if it's a new item, it's coming from the picture and it's something that I can see in the picture is true, like those angles are going to add to 180, or the little plus the little equals the big. And then step 4 is considered the manipulation of the steps above. So things that allow me to manipulate are add, subtract, multiply, divide. It could have also been substitution. This is where you'll see substitution and transitive a lot. Symmetric you'll see here. Distributive property. All of those things are manipulation things. So it's like that top half of our chart that we went over. These two sections are going to be manipulation stuff. And it's always going to be from a step above it. So if we look at some actual proofs, like I think you were working on, let's see, geometry worksheet beginning proofs. Let's start with this one. Allows me to kind of lay out some examples. And I'm just going to do a couple of examples and let you kind of get the gist. I'll do these first 3. Number 1 is an algebra proof. Your algebra proof always starts with a given. And the reason I know to start there is because it was given to me. The next thing, if I was just basically solving this equation, I would multiply both sides by 5 to get rid of it. And I can do that using the multiplication property. And when I multiply on both sides, that leaves me with just the 2x minus 9, and 1 times 5 is going to leave me with a 5 on that side. So then I'm thinking about, okay, where am I going next? The next step I would do is move that 9 over using adding 9 to both sides. So I'm going to use the addition property to add 9 to both sides, and when I do that, I'm going to be left with the equation 2x equals 14. Remember, you always want to think about, how did I get to that step? How did I get to this step that I'm on? So like for number 4, if I'm thinking about how am I going to get to the next step, well, the next step will be completely solved for, which is x is 7. And the way that I know it's x is 7 is because I've divided using the division property to get x is 7. Your proof will always start with a given, maybe 1, maybe 2, depending on how much is given in the problem. But you will never end a proof in the word prove. It's always going to be a reason that is a manipulation. All right, looking at this next proof, number 2, we have that AC is equal to BD, and that's my first step. And I know that is because it's given. So following the steps of my proof, see if I can find where I put my steps again. The first step is to look at your givens. The second step is to define your given vocabulary. Since I'm not given any vocab words in number 1, I need to move straight to step 3, which is pull things from the picture. So things that are coming from the picture are either linear pairs, segment addition, angle addition. And when I look at step 2, AC has been mentioned, but AB and BC have not. BD has been mentioned, but BC and CD have not. So these are new things. I know for sure they're coming from the picture because they haven't been mentioned before. When they're coming from the picture, I need to look at my options, which were linear pairs, segment addition, and angle addition. The fact that I'm only adding on one side of the equation and not the other tells me I should lend myself to either angle or segment addition. So it comes from, okay, well, am I adding segment pieces or angle pieces? Since there's no angle signs, I would call this segment addition property. And when I look at my picture, when I look at my picture, it says that AB, the little piece, plus the other little piece equals the big. Little plus little equals big is a good indication it's going to be either segment or angle addition. Now number 3, I've mentioned AB and BC. It was last seen here. I've mentioned BC and CD, so none of this is new, which means I'm now out of the picture phase of my proof and now into manipulation. So I need to figure out, okay, well, these last were seen here, and I'm setting them now equal to each other. So I've combined two equations into one. Anytime you combine two equations into one, it's either going to be that, let's see if I can find my little step, either going to be substitution, where we combine two equations into one, or transitive. So I need to look at the detail between the two. Substitution includes addition and subtraction signs, and transitive doesn't. Since this one has addition and subtraction signs in it that I'm substituting together, I have to call this substitution. Step 4, since we're already in the manipulation phase, we're going to continue manipulating. So I need to look at the last time I saw AB was in step 3. Last time I saw CD was in step 3. And if I look, the other side has plus BC in common. So in other words, we've got equation 3, but we've eliminated something to be left with AB equals CD. In order to eliminate BC from both sides, I would have had to subtract it. So this is regular subtraction property. And then I'm done. All right, we're going to do one last proof together. Number 3. This time we're given two things. We're given 1 and 2 things, but they've listed both of those things on the first step. So I'm still going to have 1 given because they've combined it into 1. But it can always be broken into 2 steps if I wanted it to. And then it says in angle 2, we've got angle 1 plus angle 3 equals angle 2 plus angle 4. This, to me, looks like we've discussed every piece of that, right? There's no new material. And when that happens, when there's no new material, it's a manipulation of the one above it. So things that allow me to manipulation, it looks like we took the equation 1 equals 2 and added 3 and 4 to both sides. And since I know 3 and 4 are the same, it's essentially that I'm adding the same thing to both sides of an equation. I would call this regular just addition property. We added the same thing to both sides. There's totally supposed to be an angle sign there. Number 3, we've mentioned angle 1 and 3 before, but I haven't even talked about angle ABC or angle DEF. So if it hasn't been mentioned, it's coming from the picture. When I look at just the first equation, it's saying that 1 plus 3 equals the big, and 2 plus 4 equals the big. These are little plus little equal the big equations, which when I look at my sheet, I'm only adding on one side. Adding on one side should give me an addition property with either angles or segments. And since these are talking about angles, I'm going to call this angle addition property. The last little step, excuse me, says that ABC is equal to DEF, which comes from those two equations above it. We're taking two equations and combining it into one, and I see addition signs. Two equations combining into one is either substitution or transitive. Because those add signs are there, it tells me this is going to be substitution property. All right, you guys, I hope this helped you. And please make sure if you have any questions, just email or let me know.